Greetings, fellow mathematicians! We're going to take a look at two special cases or shortcuts for applying the chain rule. Now, in the examples where we've applied the chain rule so far, we've encountered two common outer functions, a power of x, x to the n, and the exponential function, e to the x. Now, both those functions have really simple derivatives. The basic power rule and the derivative of e to the x is itself e to the x. Now, so far in the examples that we've gone through, we've applied the chain rule by first identifying the outer and inner functions. We generally call that work divide and conquer. And there's nothing wrong with that. Identifying your outer function, f of x, identifying the inner function, g of x, calculating those derivatives, and then combining them back together as f prime of g of x times g prime of x. Now, divide and conquer is nice to learn how to apply the chain rule in the beginning, but it gets to be a little bit cumbersome and tedious when you start combining the chain rule with the product and quotient rules, especially problems when you're calculating derivatives where you have to apply the chain rule several times. Writing down your outer and inner functions every time gets to be a little bit tedious. So what we're going to do is point out two special cases or shortcuts for frequently encountered functions. Instead of x to the n, or a power of x, we might be interested in differentiating a function raised to a power. And that's what we call the general power rule. And instead of differentiating e to the x, we might be interested in differentiating e raised to another function of x. And we're going to call that the General Exponential Rule. Now, how these rules work, and again, these are special cases of the chain rule, it's just shortcutting some of the work with divide and conquer. We're going to differentiate the outer function here, and the outer function, that's going to be the power of x, and we basically apply that like we apply the basic power rule. Here, for what we call the general power rule, that's for the derivative of a function raised to a power. We take the power, bring it down front, we keep the inside the same and then subtract 1 from the power. And because we're applying the chain rule, at the end, we multiply by the derivative of the inner function. We multiply by g prime. Here, g of x, that represents our inner function. Now, this is all the same work with divide and conquer, but it's just a little bit more streamlined. All right, for the other special case, what we're going to call the General Exponential Rule, we differentiate the outer function, e to the x. Well, that's just going to be e to the x. So here we get our special case for the chain rule. Differentiate your outer function, plug your inner function g of x back to that. This is your f prime of g of x term. And because we're applying the chain rule, we multiply by the derivative of our inner function, g prime. And if you want, you can rearrange that and write this as g prime times e to the g of x. And that is your derivative for e raised to a function. E raised to a function, g of x. It's really simple and quick to apply. We just basically take the function up in the exponent of e, and we bring down front its derivative. And that's going to make it really quick and efficient to differentiate exponential functions and to differentiate functions raised to powers. So let's go ahead and get to some examples on applying these. A lot of these problems are going to look familiar, very similar to when we first started applying the chain rule, but we'll be able to go through them a little bit more efficiently. Let's start with three simple examples on applying the general power rule. All of the functions here that we're going to be differentiating are of the form a function raised to a power. Our first problem is going to be really simple. The way we apply the general power rule is we differentiate the outer function, the power of x, by bringing first the power down. So bring down 100. We're going to keep the inside the same. That's g of x. So we keep that inside as x to the fourth plus 1. But applying the power rule, we subtract 1 from that exponent. And the last step, we multiply by the derivative of our inner function. The derivative of x to the fourth plus 1, that comes out to 4x cubed. And that is it. You get the same answer as we would have earlier by applying divide and conquer, but now this is so much faster. All right, our second problem, this is very similar. We have a function raised to now a fifth power. So we start by differentiating this with the general power rule. We bring the power 5 out front, keep the inside the same, subtract 1 from that power, so we get now 1 plus cosine of x to the fourth power. And because we're applying the chain rule, but we're applying the chain rule in the special case that we're calling the general power rule, now we multiply by the derivative of the inner function. And if we differentiate 1 plus cosine of x, that comes out to, for its derivative, negative sine of x. And that's it. Now, so far in problems 1 and 2, you can simplify those answers. You can take the factor of 4, multiply it to 100. Same thing with the negative here. You can multiply that out front, but you should be comfortable simplifying those at this point. All right, now the last example where we're going to apply the general power rule, this is a very common type of function, a power of a trig function. So make sure you're comfortable immediately recognizing sine cubed of x as sine of x all cubed. Now you can rewrite your function like this before you differentiate, but let's try to keep it written as it's given. So if we apply the general power rule here, instead of the power being on the outside, we understand the power there, the outer power, that's the cube there, sine cubed of x. So we apply the general power rule. We're going to bring the 3 down. We keep our inside function the same. Our inside function is sine of x, but we subtract 1 from that power. So we get now sine squared of x. But because we are applying the chain rule, and again, this is now the special case of the general power rule, our inner function is sine of x. The derivative of sine of x, the derivative of your inner function, that's cosine of x. So we multiply here by cosine of x. And you can see this looks much, much quicker than earlier when we would have gone through the work with divide and conquer. You get the same answer, but just a lot faster. All right, these were all examples on applying the general power rule, functions raised to powers. Let's go ahead and take a look at some examples on applying the general exponential rule. With the next 3 examples, we're going to see that the general exponential rule is a ridiculously fast shortcut. Now let's just make sure you understand what the general exponential rule says. When we differentiate e raised to a function, we basically get that exponential function back, e to the g of x, but we just multiply by the derivative of the inner function, g of x. We multiply by g prime. So here, our inner function, that's whatever's up in the exponent of e. And the examples where we apply this will go really quick. So let's get right to the first one, differentiating e raised to the function 3x. We're going to differentiate the inner function, 3x. That derivative comes out to 3. So we get here as a derivative 3 times e to the 3x. And that's it. There's a nice pattern here which is worthwhile to point out. Anytime you differentiate any sort of exponential function, you always get that same original exponential appearing in your answer for the derivative. And we see that pattern here. The extra factor of 3, that's just the derivative of the inside. All right, next, problem 2. We just need to differentiate the inner function x squared, and that's again ridiculously fast. The derivative of x squared is 2x. So we get as our derivative 2x times e to the x squared. For our last example, we're going to incorporate some trig functions. To calculate this derivative of e raised to the tangent of x, we just need to know the derivative of tangent, and that's secant squared. So we get as our derivative secant squared of x times our exponential function, e to the tangent of x. And that's it. Now, hopefully you're getting the hang of how to apply these special cases, the general power rule, and now the general exponential rule. These are going to be really, really helpful, again, when you start applying these with other differentiation rules, problems where you're applying chain rule with the product rule, chain rule with the quotient rule, especially the problems where it's several applications of the chain rule all in a row. Hope you enjoyed this video. I hope this helped with your Calculus 1 course. If you're learning a lot, support the channel, like and subscribe.